What if the first freeze of this year doesn't creep in slowly, the way it usually does, but slams into entire states almost overnight? Right now, in the upper layers of our atmosphere, something is quietly shifting, and meteorologists are watching it with real concern. A pattern is forming that could push the first real freeze weeks earlier than anyone expected, catching millions of people completely off guard. Stick with me for the next few minutes, because by the end of this video, you will understand exactly why this year's cold could arrive faster, harder, and sooner than history says it should. Before we go further, welcome back to Universe Proof, the channel where we take the biggest questions about our planet, our atmosphere, and the universe around us, and break them down in a way that actually makes sense. If you're new here, this is exactly the kind of story we love digging into, so stick around because today's topic connects weather, ocean currents, and the upper atmosphere in a way most people never even think about. So let's start with the basic question everyone is asking. Why would 2026's first freeze arrive early at all? The answer isn't just one thing. It's actually three separate forces lining up at almost the same time, like gears clicking into place. On their own, each one would only cause a mild ripple in the weather. But together, they create the kind of setup that meteorologists describe as rare, and in some reports, they've used the word extraordinary to describe what's forming above our heads this year. The first piece of this puzzle is something called El Niño. And this year, it isn't just any El Niño, it's shaping up to be a super El Niño. That means unusually warm water spreading across a massive stretch of the tropical Pacific Ocean. Forecasters are now saying there's a very high chance, somewhere around 80%, that this El Niño will reach a very strong intensity by the final months of the year. And it's expected to stick around well into early next spring, not just fade away quietly like some past events have. Now here's the twist that most people don't expect. A strong El Niño usually gets blamed for warmer winters, and in some regions, that's exactly what happens. But a super El Niño doesn't just warm things up evenly, it reshapes the entire jet stream, the fast river of air high above us that steers storms and cold air masses across the country. When that river bends and twists in unusual ways, it can send pockets of brutally cold Arctic air diving south into places that normally stay mild well into December. The second piece of the puzzle sits even higher in the sky, in a place most of us never think about, called the polar vortex. This is a massive spinning pool of freezing air that normally stays locked up near the North Pole, circling around and around like a giant frozen whirlpool. When it stays strong and tight, cold air stays trapped up north, and we get a fairly normal winter. But when that spinning vortex gets disturbed, stretched, or even split apart, the door to the Arctic swings wide open. This year, long-range data is already picking up early signs of a polar vortex disruption, with a noticeable weakening signal expected around January and February. But here's the part that should really catch your attention. Some of this disruption behavior is starting to show up earlier than models originally predicted. That early wobble in the vortex is one of the biggest reasons scientists are now saying the first real freeze could hit far sooner than the calendar usually allows. The third factor is one that barely gets talked about outside of scientific circles, and it's happening thousands of miles away in the Arctic Ocean itself. Sea ice levels in certain regions, especially around the Barents and Kara Seas, are sitting unusually low this year. At the same time, ice levels near the Sea of Okhotsk are actually running higher than average. That imbalance might sound small, but it changes how heat escapes from the ocean into the atmosphere, and that shift can ripple all the way down into the jet stream pattern over North America. Think of Earth's atmosphere like a giant interconnected machine where every gear touches another gear. Warm ocean water in the Pacific pushes on the jet stream. The jet stream pushes on the polar vortex. The polar vortex pushes on how much cold air escapes toward us. And low sea ice in specific Arctic regions adds even more fuel to that chain reaction. None of these forces act alone. They feed off each other, and this year, all three appear to be lining up at nearly the same time. So what does this actually mean for you, sitting wherever you are right now watching this video? It means the classic pattern of a slow, gradual slide into winter might not happen this year. Instead of temperatures easing down bit by bit through October and November, some regions could see a sudden temperature crash, the kind where one week feels like early autumn and the very next week feels like the deep middle of January. That kind of whiplash catches people, farms, and even power grids completely unprepared. Meteorologists have actually started warning about this exact scenario, describing it as a possible fork in the road for how this winter season unfolds. Down one path, the cold arrives on a more traditional schedule. Down the other path, an early polar vortex disruption combines with the reshaped jet stream from El Niño, and cold air breaks free far ahead of schedule, sometimes even before winter has officially started on the calendar. This isn't just theory sitting in a lab somewhere either. Similar early disruptions have happened before, and when they did, regions from the northern plains all the way through the Midwest and into the eastern half of the country experienced sudden sharp temperature drops weeks before residents expected them. Snow that usually waits until deep December showed up while people were still raking leaves. Roads that were dry and clear turned icy almost overnight, catching drivers completely off guard. One of the trickiest parts of this whole pattern is that a super El Niño often creates a deceptively mild-looking seasonal average. On paper, the overall winter might look warmer than usual, and that's technically true when you average every single day together. But averages hide the real danger. A season can look mild on a graph, while still containing sudden, violent cold snaps buried inside it, the kind that catch entire regions off guard precisely because everyone was expecting a gentle winter. That's exactly the warning meteorologists are raising this year. A mild background does not rule out a dangerous cold outbreak, it can actually hide one. The biggest risks aren't just about how cold it gets, they're about how fast the temperature changes. Rapid shifts from rain to snow, sudden freezing rain events, and quick thaw to freeze cycles tend to cause more damage and more danger than a steady, predictable cold season ever could. If you're picturing this only affecting one corner of the country, think again, because this kind of pattern rarely stays contained. When the jet stream buckles under the combined pressure of a super El Niño and a stressed polar vortex, cold air doesn't politely stay in one region. It can surge down through the central plains, spill east across the Great Lakes, and even reach areas that rarely see an early freeze at all, catching agriculture and infrastructure completely unprepared for the timing. There's also a piece of this story connected to the wider stratosphere, the layer of atmosphere sitting well above where our regular weather happens. Scientists are tracking something called a westerly wind anomaly high above the tropics, which sounds complicated, but essentially acts like an extra push that can help nudge the polar vortex toward disruption. When this wind pattern lines up with a strong El Niño, it increases the odds of that vortex wobbling or splitting even further. So why does all of this matter beyond just knowing when to grab a heavier jacket? Because early, sudden freezes carry real consequences. Crops still in the ground can be damaged before harvest is complete. Power grids that expect a gradual demand increase can get hit with a sudden spike in heating needs all at once. Roads and travel systems built around a predictable seasonal transition can be caught completely flat-footed by ice and snow arriving ahead of schedule. And here's something worth sitting with for a moment. The very forces driving this potential early freeze, unusual ocean warmth, a wobbling polar vortex, and shifting Arctic sea ice are the same broad categories scientists watch when studying how our climate system is evolving over time. This doesn't mean every early freeze is directly tied to long-term climate shifts, but it does show how sensitive and interconnected our atmosphere really is, reacting to changes happening in oceans and ice thousands of miles from where you're sitting right now. At Universe Proof, this is exactly why we love breaking stories like this down, because weather isn't random noise, it's the visible result of enormous systems interacting far above our heads and far out across our oceans. When you understand the super El Niño building in the Pacific, the wobble forming in the polar vortex, and the sea ice imbalance up in the Arctic, the story of an early freeze stops being a mystery and starts making complete sense as one connected chain of cause and effect. Let's talk timing for a moment, because that's usually the question everyone actually cares about. Historically, when a strong El Niño and an early polar vortex disruption have appeared together in the same season, the first noticeable cold outbreaks have shown up anywhere from late November through the middle of December, well ahead of the traditional deep winter chill that normally waits until January. That doesn't mean every single region freezes at once, but it does mean the window for an early cold snap opens up much wider than usual this year. The regions most likely to feel it first are typically the ones sitting directly under the path where the jet stream dips southward, often stretching from the northern plains, across the upper Midwest, and down into parts of the Ohio Valley. From there, cold air has a tendency to keep sliding east and south, eventually reaching areas that don't usually brace for freezing temperatures until much later in the season. If the vortex disruption ends up being as strong as some of the early signals suggest, even the southeast could see an unusually early taste of true winter cold. It's also worth remembering that these atmospheric patterns rarely announce themselves with a neat, clean start date. Instead, they tend to build gradually behind the scenes for weeks before suddenly breaking loose all at once, which is exactly why so many people end up caught off guard. One week, the forecast looks completely ordinary, and then, seemingly overnight, meteorologists start issuing warnings about a major cold outbreak that was actually forming quietly in the stratosphere the entire time, far above where our daily weather usually gets its attention. Based on everything scientists are currently tracking, the honest answer is that it's a real possibility worth taking seriously, not a guaranteed certainty carved in stone. Long-range forecasting always carries uncertainty, and these patterns can still shift in the coming weeks. But the ingredients for an early sharp cold outbreak are lining up in a way that has genuinely caught the attention of meteorologists watching this season unfold in real time. There's one more angle worth mentioning before we wrap this up, And it has to do with how prepared or unprepared most infrastructure actually is for a sudden early cold snap. Power companies, road crews, and even everyday households usually plan around a gradual seasonal transition, stocking up on supplies and adjusting routines slowly as temperatures drop bit by bit. When a freeze arrives ahead of schedule instead, that slow buildup gets skipped entirely, and systems that were never stress tested for an early shock can struggle far more than they would during a normal, gradual winter onset. If there's one thing to take away from all of this, it's that keeping an eye on the actual pattern matters far more than just checking a single day's forecast. Watch for early signs of polar vortex stretching, watch for how the jet stream behaves through the coming weeks, and don't let a mild-looking seasonal average lull you into a false sense of security. The setup for a sudden early freeze is very real this year, and being aware of it now means you won't be caught off guard when it actually happens. Before you go, I want to ask you something. Do you think this year's freeze will arrive earlier than usual where you live, or do you think the pattern will break in the other direction? Drop your prediction in the comments below. I genuinely read through them, and it's fascinating to see how different regions are already feeling the shift. If this video helped connect the dots for you, do me a favor and share it with someone who's been wondering why this winter feels different already. It genuinely helps this channel keep making videos like this one. That's the story of why 2026's first freeze could sneak up on all of us far sooner than the calendar suggests. Driven by a super El Niño reshaping the jet stream, an early wobble forming in the polar vortex, and an unusual imbalance in Arctic sea ice pulling all the strings together at once. Thanks for watching all the way to the end here on Universe Proof. Make sure you're subscribed so you don't miss what we uncover next, and I'll see you in the very next video.